What happens if Pythagorean theorem sides are not integers? Have you ever wondered what occurs when the sides of a right triangle do not consist of whole numbers? This question leads us to the fascinating world of the Pythagorean theorem and its applications. The Pythagorean theorem tells us that in a right triangle, the square of the length of the hypotenuse equals the sum of the squares of the other two sides. When the side lengths are integers that satisfy this relationship, they form what we call a Pythagorean triple, like 3, 4, and 5. But what happens when the sides are not integers? Well, the triangle can still be a right triangle, but it will not form a Pythagorean triple. Instead, the lengths may involve irrational numbers. These are numbers that cannot be expressed as simple fractions or whole numbers. For instance, if you have a right triangle with legs measuring 1 unit each, the hypotenuse will be the square root of 2, which is an irrational number. This means that the side lengths are not whole numbers and cannot be scaled to integers without losing their exactness. Such triangles are still valid right triangles, but their side lengths do not share a common unit length that is an integer multiple. This situation highlights an important aspect of geometry. The Pythagorean theorem applies universally to all right triangles, regardless of whether the side lengths are integers, rational numbers, or irrational numbers. The theorem focuses on the relationship between the squares of the sides, not the actual lengths being integers. Non-integer side lengths often come up in real-world measurements and geometric constructions, where exact integer lengths are not always available. When the side lengths are not integers, calculations using the Pythagorean theorem may yield decimal or irrational values. This requires using approximations or numerical methods for measurement and construction. For example, if one leg measures 10.5 units and the other measures 5.2 units, you can calculate the hypotenuse by squaring these lengths, adding them together, and then taking the square root. The result will be a non-integer length. So, if the sides of a right triangle are not integers, the triangle still satisfies the Pythagorean theorem, but the side lengths do not form a Pythagorean triple. Instead, the sides may be irrational or decimal numbers, showing that the theorem is applicable beyond just integer solutions. This understanding helps clarify how right triangles and their side relationships work, making it easier to grasp geometry with both whole numbers and more complex lengths.